The issues that the M16 rifle faced in service in Vietnam have been the product of a lot of controversy, and with that controversy have come a lot of misleading or perhaps even misinformed information about the subject. In this video, I aim to correct a lot of the deficiencies that I found in presentations of these facts in other places. Oftentimes, one issue the rifle faced is overstated or misrepresented or taken out of context, and what I'd like to do is try and get a concise look at the big picture of what really went wrong with the M16 in Vietnam. Now, before we launch into the actual presentation of that subject, what I would like to do is get a couple of housekeeping items out of the way. I am of the opinion that no presentation can really be better than the introduction that starts it, so we're going to get a couple of things out of the way here in the beginning before we really get into the meat and potatoes of the issues that the rifle faced. Starting off, I want to address the question of why does this matter? I would say that at once there's two buckets, two different ways that you can look at this. The way that I favor looking at it is that it is very important, not just for the historical implications, but also for a variety of engineering reasons. At the end of the day, the issues that the M16 rifle faced had something to do with politics, but was more a study of the engineering difficulty of taking a product that's really only seen low rate production, scaling that up to very high rate production, and then at the same time, putting it in a use case that it hasn't ever actually seen before. Of course, product testing can only get you so far, but when the thing's in the hands of the users that are actually meant to use it, or that testing was meant to emulate, generally speaking, products will go a little bit off the rails. And I think that the study of this history is very important to get correct, because in order to understand both the historical and political implications, as well as to understand the engineering implications, it's important that we understand a fuller picture than usually gets presented when talking about this story. However, I mentioned there was a second bucket. In the second bucket, I would say that there is a strong argument where you could say that all of these events and all of this quote-unquote controversy just doesn't matter. I don't want to elaborate too much on this now because I will plant the seed and then we'll water it throughout this presentation. But ultimately, when it comes to rifles in military service or other similar engineering projects in military service, they're all going to have some amount of teething issues, and the teething issues that the AR-15 faced is far from extreme, especially if we compare it to some of the rifles that came before it. And I'm not just talking about the M14, I'm also talking about the M1 Carbine and the M1 Garand, each of which faced a series of engineering hurdles and reliability issues that in many cases eclipses the problems that the M16 itself had. Yet the M16 is remembered one way and the Garand is remembered a very different way. So by the end of this, we'll elaborate more on why in the end perhaps this controversy doesn't matter, and it's a little bit of a tempest in a teapot or selective outrage sort of situation. The next part of our introduction, right? Why should you guys listen to my presentation on this? What sort of credentials do I have? I've spent hundreds of hours researching this. It's always been a topic that's been deeply interesting to me, and I found that a lot of the presentations out there about it either conflicted with the historical record or conflicted with themselves or conflicted with other accounts and other retellings, and this led to me to have this sort of desire to understand the topic at hand better just for my own purposes, and as I came to understand it better, I found that so many of the presentations that are out there are a little bit crummy. In a moment, we'll sort of talk about why or how you could tell that a particular presentation is a little bit defective, but I found that so many of them were that I wanted to put a presentation like this together. I've made other videos about this subject in the past, and I'll point you towards those as we go along, because some of them deal with a little bit more laser focus on particular issues the rifle faced, but the purpose of this video is to give a much higher level overview of the most serious issues that were facing the rifle, and then those other videos perhaps drive into a little bit more detail on those particular subjects. The sources that I'll be pulling from for this presentation are Ed Ezel's The Black Rifle M16 Retrospective and Report of the M16 Rifle Review Panel. These two sources have a wealth of information on understanding not only what issues the rifle faced, but what the effect of those issues were, what it took to solve those issues, and what actual failures in the rifle went away or changed or were improved or perhaps even worsened by each change that took place. I will leave links to these sources in the description if anybody's curious about this subject in general. I seriously recommend you check them out. Read them in their entirety. It will greatly increase your understanding of this topic if you read these two, especially if you read them more or less side by side, because you'll find things that are summarized in Ezel's book that are gone into in detail in the Rifle Review Panel. And between the two of them, you'll have a really good understanding of the issues that the rifle actually faced. On the topic of sources, I will advise you to avoid relying too heavily on certain books, such as Misfire, or even some of Ezel's earlier writings, such as The Great Rifle Controversy, because in both cases, they rely on backwards reasoned conclusions that come back to the I-Court hearings. The I-Court hearings are an important part of the M16's story. However, the I-Court hearings are important from a standpoint of demonstrating how little was actually understood at the time about the issues the rifles were facing, and how anxious Congress was to point fingers in a direction without even having a really good idea of what was actually wrong with the gun or its ammunition. And so while I'm not telling you to engage with these sources at all, there are some sources out there that have information that's not entirely correct. A lot of people who study this subject read the I-Court hearing transcripts and assume that everything that's said there must be factual, when in reality there's a lot of stuff that's said there that isn't factual, and the ultimate conclusion of the I-Court hearings point in one direction that, whenever you go and look at the facts and the data, really don't tell a very accurate picture. Now, the last couple of housekeeping items that I'd like to get to is to reiterate, a lot of the information out there about this topic is really bad. It ranges from misleading to outright wrong, from ill-informed to poorly informed. I'm assuming that if you've clicked on this video, you've probably heard some version of the M16 story before that goes something like this. The Army changed the powder and that made the rifle bad. If that's your conception of what happened here, I'm going to ask you to sort of put a pin in that, maybe put that on hold, suspend your belief in that version of the story, and hear this presentation out. You're going to hear a lot of things throughout this presentation that will demonstrate to you why that's not really a very accurate picture at all, and why anybody who's sort of shopping that sort of a summary, that sort of an understanding of the events, probably didn't pay a whole lot of attention or do very much research into what actually happened with the rifle. Because, as our second item there listed says, there's a whole lot of moving parts in this story. It's difficult to keep up with a lot of these moving parts because there's just so much going on and it happens in such a short time frame. I've done my best to try and condense that down so we can just focus on the facts with a minimal amount of conclusions or inferences drawn from those facts, and I will leave those inferences up to you by trying to give you enough facts that your inferences can really only point in one particular direction. As I have there listed as the third item, I would like to try and identify my conclusions when they pop in, but I'm trying to keep that to a minimum. I think that's sort of a failure of a lot of other presentations on this subject because they start interjecting their own opinion or their own interpretation of what they think is happening, and usually when they're doing that because they haven't done enough research to fill in the very obvious blanks that exist. A lot of the time that this story gets retold, those blanks are filled in by saying, well, the Army said, well, the Army did this, and the Army's bad, and the Army's wrong. And the reason for a lot of this is because the I-Court hearings tried to pin everything wrong that happened with the rifle on the Army, when in reality the facts of the matter certainly don't actually paint the Army as being responsible for even a fraction of as much as people want to attribute to them. Finally, the format that I'm going with here, sort of a slide deck that I'm talking over, I hope will make this subject a little bit easier to grapple with, maybe make it a little bit more bite-sized information so it's easier to swallow. I'm hoping that it doesn't feel too academic or overly academic. Of course, you guys can leave me a comment in the description if you think that me talking in front of a prop gun or whatever is a better format, but I felt like I'd give this a try. And finally, the goal statement for this presentation is that I am trying to give you a concise understanding, but not a comprehensive study of this topic. A comprehensive study would result in an hours long video, probably have to drag in more sources, and would be something that's very difficult to digest. I'm trying to avoid that as much as I can. And with that said, I will point you back to the first two items on this list and tell you that that is the core of my thesis in this presentation, that there is a lot of bad or incomplete information about this subject that gets presented, and this is either because there's so many moving parts and people aren't aware of that, or because there's so many moving parts that people want to summarize, and they summarize in a way that they haven't really done all of the research, and then end up putting out a presentation that's something between misleading and just outright incorrect. With that said, we are ready to jump into the presentation itself, and in this presentation we will cover 5 key issues. These issues, in the order we will cover them, will be the initial powder selection, the buffer design, insufficient instructions/cleaning, chrome plating, and general immaturity. Between these 5 key issues, you will find the root of most of the rifle's problems. By the time these 5 items are addressed, the rifle finds itself as one of the most reliable military firearms that has ever been fielded. Before these 5 issues are addressed, there's conflicting reports of the rifle's performance coming out of Vietnam. Some reports saying it works well, some saying that it has some problems, and some saying it doesn't work at all. This is the situation that Colt, the Army, the Air Force, even Remington and Winchester's engineers all have to deal with unraveling, and I hope that this presentation can give you some perspective of being in their shoes and having a wide number of conflicting reports of things that could possibly be wrong and having to sort of piece together the puzzle of what's actually wrong with the gun and what can actually be done to fix it. Finally, before we jump into our first issue, I would like to call attention to the fact that these issues are not listed here in any sort of order of severity. So without further ado, let's jump into the initial powder selection. I will begin the discussion of this issue by saying I have done a video with a laser focus on this issue specifically because there is so much misinformation out there around it. It delves into quite a bit of detail, and if you're interested in more discussion than takes place in this video on the subject, I will have a link to that video in the description for you guys to dig into there. But for the purposes of understanding the issue at a little bit higher level than that, when the cartridge that would eventually become 223 Remington was initially designed by Eugene Stoner, IMR 4475 powder was specified as the powder to use. Eugene Stoner was familiar with this powder. It had been used historically to load 7.62 by 51, also known as 7.62 NATO, also by this time known as 308 Winchester. And Eugene Stoner, who had experience making guns for this caliber before it was commercially available, certainly would have had to have had some level of exposure to hand loading for it, and would have been aware of the fact that 4475 had been used to load it. So this is our most likely explanation for why Eugene Stoner would specify 4475 in the first place. Now, we do know from his correspondence and his statements later in life that his initial specifications for 223 Remington were essentially a first best guess. He sort of looked at the requirements that the Army had tendered to Armalite as far as the cartridge that needed to be designed, evaluated what it would actually take to meet those requirements, and by the time that he had the final requirements from the Army, had found that 222 Remington wouldn't quite have enough juice to get the job done, but by bumping the case neck forward and using a boat-tailed bullet, he would be able to get the specs that the military wanted using IMR 4475 powder. However, Eugene Stoner did this in a matter of a month or two, and he certainly didn't have time to sit down and do detailed pressure testing data. The thing that he didn't realize is that in order to get 223 Remington to accelerate a 55 grain projectile to the velocity that the Army required, as well as to meet the ballistic tests that the Army had laid out, 4475 would have to be pushed past the safe operating pressure for 223 Remington. The Army had established a max pressure that was allowable, and 4475 at its nominal condition would be pushing just slightly over that pressure level to get the spec 3250 foot per second that the Army was asking for. For the Army's initial testing of Armalite's AR-15s, this wasn't a very big issue because Stoner and the team at Remington loading the ammunition could simply pick lots of 4475 powder that had a pressure burn rate that resulted in slightly lower than average pressures, resulting in pressures that were typically below that max average pressure limit. However, even in that early testing, the Army did note pressure signs were showing up, primers were being ejected from rounds, and there was the usual telltale signs of being near, if not punching over in some instances, that max average pressure. For those unaware, whenever we say pressure signs, what we mean is that we see indications that there's an overpressure situation going on with the fired round. This can look one of many ways: pierced primers, primers that are ejecting themselves, primers that are protruding, cases that start bulging in their unsupported regions, or case heads that start to look like this one on the left where the entire thing is sort of prolapsed. These are all indications that overpressure situations are existing. And these sort of scenes wouldn't be unfamiliar to the early Army testing of the Armalite AR-15s, because 4475 loaded ammunition would be at risk of overpressure. And when we say at risk of overpressure, what we're talking about is sort of the statistical definition of risk, where some ammunition with some lots of powder are going to deviate on the slightly higher side, even with their hand-selected lots of powder, which necessarily means that eventually you're going to have some rounds that are pushing over that safe, acceptable limit, and so you're going to see primers ejected or cases start to want to fail, bulging and prolapsing, and all these sorts of issues going on. However, this was all still very developmental, and so there wasn't a decision made to address it at this point. But it was noted. The Army did note there was this pressure issue existing. And of course, for those unaware of why this is a problem, ammunition running a little overpressure typically isn't an issue. The problem with military powders, though, is you generally have a plus or minus 10%, or even in some cases plus or minus 15% over what your nominal pressure is. On the minus side, you're generally going to be okay, but on the plus side, you can start getting yourself into trouble. In the case of 223 Remington, being 15% over nominal, when your nominal was already riding the line of the max average pressure, means that you could be as much as 15% over what that pressure limit was. This is the point whenever you start to have case failures happen, you can have primers blown out, and certainly over extended use, you might get yourself into a situation where a gun could explode. This is why max average pressure limits are established and why you're supposed to generally stay under them as best you can. For those early trials, and even after Colt acquired the design and Colt's trials and tests started, and even Colt's early combat testing of the rifle was going on, the actual amount of ammo that was being ordered could be suited by just taking those lots of 4475 powder that was burning on the lower pressure average side of things and using that to load your 223 Remington ammo. The issue of 4475 generating overpressure conditions really wouldn't get addressed until 1963 and 1964, when the Department of Defense would have committed both the Army and the Air Force to using the AR-15 and had procured about 100,000 rifles for the branches to be using. Now, alongside this rifle order, a large quantity of ammunition also had to be procured. Through a series of several orders, both the Army and the Air Force would go out to ammunition manufacturers and try and procure ammunition that met the specs. Of course, there's a max average pressure associated, there's a spec velocity associated, and a projectile weight specified. It's at this point that 4475's overpressure condition rears its ugly head again. Having not yet been resolved, ammunition manufacturers are stuck between a rock and a hard place. They can't actually get enough hand-selected 4475 powder lots that burn on the lower half of the pressure range in order to meet the demand for ammunition orders that they're getting. Most ammunition companies outright refuse to bid on the Army and the Air Force's contracts for this ammunition because they cannot guarantee that they'd stay under the max average pressure, that they could get the spec velocity with the spec bullet weight without that overpressure risk existing. If that overpressure condition is there, the Army and the Air Force can just outright refuse to pay for the ammunition that they've received because it fails to meet specifications. Ammo manufacturers aren't willing to accept that corporate risk, and they certainly wouldn't be interested in taking that personal safety liability risk, because nobody wants to deliver ammunition to the United States government that's going to be unsafe for soldiers to shoot. That's sort of alienating your primary customer at that point, and it's just bad business, and it's not safe because getting people hurt at the end of the day is kind of counterproductive. And the people that these ammo companies were sort of hoping that their ammunition would be used to hurt would ideally be communists and not people who were U.S. citizens who weren't communists who had just had their rifle explode. Ultimately, it's Remington that puts their foot down on an order for 223 Remington ammunition that came from the Air Force. Remington said that they would not use 4475 to load this lot of ammunition and proposed WC-846 ball powder as an alternative. Now, this should be strange for one primary reason. If you're familiar with the corporate structure of the ammunition manufacturers around this time, Remington owns DuPont, and DuPont owns 4475 powder, right? DuPont is the manufacturer, the sole manufacturer of that powder. It's a little strange for Remington to defer from their 4475 powder and say, we've tested and found that our competitor, Olin's powder, actually works better. Olin was owned by Winchester, right, the Winchester Ammo and Gun Company, and was a direct competitor to Remington, especially as it came to their ammo divisions. However, Remington, and especially DuPont, were probably well aware of the fact that 4475 just was not an acceptable solution for loading 223 Remington, and if any money was going to be made on the loading of 223 Remington ammunition, it was going to have to be using a different powder. The Air Force, the Army, and all of the concerned parties in getting the AR-15 adopted and into service were aware of the fact that the ammunition manufacturers weren't willing to use 4475 powder, so they began looking at alternative powders. Initially, they don't actually consider WC-846, and they make Olin justify its inclusion through a written letter. Olin supplies this letter and the powder is evaluated, and after a quick series of tests, the data is pretty clear. WC-846 is going to be the powder that gets you the velocity you want at chamber pressures that are safe. This sets in motion the chain of events that I like to refer to as the powder change, and again, that's the subject of that other video that, again, is linked in the description if you want more details on it. Ultimately, it was Remington's objection to something that Stoner had specified a long time ago and just had never actually gotten addressed or fixed that became the genesis of the powder change. 4475 simply was not an acceptable powder to use, and an alternative needed to be found. If a new powder wasn't going to be found, the Army and Air Force had a very limited number of options. They could suffer with about a tenth of the ammo that they actually needed, which means that they'd only be able to field about a tenth of the AR-15s they needed, which means they're going to have to go and find a different gun somewhere else, which at this point is going to be very difficult for them because M14 production is shut down. One plan that does get drawn up is turning back to the Garand and quickly converting them to fire 7.62 NATO ammunition. I hope I don't have to explain to people why chamber sleeves in 30-06 Garands to try and convert them to 7.62 NATO wouldn't have been a very good option. Another alternative option would have been for the Army and the Air Force to sit down and agree to lower the spec velocity standard that they had just spent a lot of time testing and evaluating 223 Remington for. This certainly was an option, and it was considered. The issue with it is that you'd have to step your velocity down by about 250, almost 300 foot per second in order to get 4475 to the point where any 4475 could be used to load 223 Remington without risk of overpressure. While it's easy to say, well, that's an option, we could just reduce it by 300 foot per second, perhaps a better way to frame this is by comparing a 20-inch barreled AR-15 to a 14.5-inch barreled AR-15. Your difference at the muzzle is there right about 250, 300 foot per second. The difference in ballistic performance between a 55 grain projectile leaving a 20-inch barreled AR versus a 14.5-inch barreled AR is demonstrable. There's a difference in the effective range of the weapon, and there's certainly a difference in the actual effectiveness on the target, resulting from that difference of only 300 foot per second. A lot of this has to do with the actual terminal effects of 223 Remington. It's very velocity dependent in order to cause a lot of damage on impact, and so reducing your velocity 300 foot per second at the muzzle as a reconciliation for the powder that you had picked really isn't a very smart option, especially when you have a powder that's going to get you the performance you want at chamber pressures that are safe. This chart that I put together sort of goes through the key points in the powder change. Again, I refer to this chart in my video specifically on the subject, but the key thing to keep in mind here is that the powder change was essential. It needed to happen because you really only had two other options. You go back to using M14s and or converted Garins, which is just not going to work very well. I hope I don't have to explain to everyone why that is. Or you suffer the consequence of having a substantially nerfed velocity on 223 Remington and limiting its range pretty substantially compared to where it was actually designed to be. Now, had that change been made, there would have had to have been a litany of changes to the rifle in order to get it to cycle and perform reliably with this reduced power ammunition. This means that you're going to have about a year or two of tweaks and changes to the rifle necessary to get it to work reliably again. If we consult this chart of what happened as a result of changing to WC-846 powder, we see that it took about a year or two to adjust the rifle to the ammunition that was going to end up being used. All this to say, if they were going to stick with 4475 powder, in order for them to have enough of it, they would have had to have reduced spec velocity. That reduce in spec velocity is going to reduce gas port pressure as well. That reduction in gas port pressure is going to drive design changes back into the rifle. These design changes are going to take time to work out. The change to WC-846 also drove changes, but it's the same sort of changes that would have happened from reducing the pressure with 4475 loaded ammunition. So ultimately, a powder change had to happen no matter what. The powder change that was chosen, picking WC-846 and not sacrificing on your terminal ballistics, is, in my opinion, the correct decision to have made. Now that we've mentioned it, that increase in gas port pressure that you got with WC-846, right, made the rifles cycle faster, more energetically. This increase in cycling rate caused two things to happen. One of them was it exposed the inadequacy of the rifle's original buffer design, and we'll cover that in the next section. The other thing that it caused to happen is premature parts failure and wear in the rifle. As you'd expect, having the rifle cycle faster with more energy in its system means that the parts in the gun are going to get beat up a little quicker, and Colt would have to beef up and reinforce various parts of the rifle in order to deal with that increase in cycling energy. Certain parts like the disconnector or the bolt stop or even extractors started failing at higher rates than they'd seen before, and this was fairly attributed to that increase in cycling energy. Colt would have to improve heat treatment and manufacturing and design specs on some of these parts to make them a little bit stronger so that they'd hold up better. Ultimately, by the time that the improved buffer design was implemented and the rate of fire was slowed back down, the improved strength and design on these parts becomes a net benefit for the rifle. These parts were things that were going to get wore out either way, and so having them beefed up to deal with a worse operating condition than you're now actually subject to is in the end a good thing. This isn't to say that the increase in cycling velocity didn't cause problems, because certainly premature parts failure is an issue that the rifle then did have to deal with. However, the parts that would end up failing due to that increase in cycling velocity were probably due a redesign at some point in the rifle's future anyway, and having to deal with those parts failing prematurely gave them the opportunity to get fixed earlier rather than later. While this certainly isn't a good thing and is much more like a silver lining on an otherwise bad situation, the overall number of failures that are directly attributable to those parts that failed as a result of the increased cyclic rate pale in comparison to the failures that you'll see for many of the other issues that we'll discuss, and should be viewed in that context. That The parts failures was a problem, but it was a problem for guns that had fired a large number of rounds. The worst issues that the rifle was facing were issues that prevented it from firing a large number of rounds in the first place, right? If you're fortunate enough to get a gun that after 10,000 rounds has a parts break, that's not as bad as a guy that had a gun that couldn't fire 1,000 rounds because the thing just doesn't work at all. While there's no real evidence to suggest that the powder change was responsible for those rifles that wouldn't work whatsoever, some of the issues that we'll look at later in this presentation will be those issues that resulted in guns that were pretty darn close to completely non-functional. This is a lesson that will end up repeating itself a good 30 years in the future with the introduction of the M4. Of course, on the surface, the M4 is really just like a short M16. However, shortening the M16 down again increased the rate of fire and again increased the wear and tear on internal parts of the rifle. As the M4 was initially conceived, it was a carbine, right? A rifle for people that don't actually need full-size rifles. However, Special Forces took an interest in the compact size of the M4 and ended up pushing it beyond its original operational capabilities, putting more rounds through it than they had initially expected and putting more rounds through it more quickly than they initially expected. And much the same way things had unfolded 30 years before, parts in the M4 would end up breaking and have to be reinforced and redesigned and beefed up by Colt. The reason I bring up the M4 is that these days the M4, and especially the M4A1, are thought of pretty fondly. However, it faced more or less the same exact pattern of teething issues in this regard as the M16 faced. While the M16 is derided for it, the M4 most of the time these days is lauded for it. And I just want you guys to keep that in your back of your mind for that second bucket that I mentioned at the very beginning of this presentation, about why these facts might not actually matter that much at all. Is that in the case of the M4, at the time it was sort of big news that the rifle was having issues, but 10 years removed from that, people didn't really seem to remember that the M4 had those issues. Meanwhile, nobody has managed to stop talking about the M16's issues ever since they showed up. Ultimately, with a series of parts reinforced and with the improved buffer implemented, the powder change ended up being permanent. WC-846 powder has stuck around ever since, and while it did eventually have its calcium content controlled to a lower bound, this was done to combat a rare issue where sometimes calcium buildup would happen inside of gas tubes, and was noticed well after the time that everybody considers that the M16 was quote-unquote fixed. Finally, wrapping up our discussion of the powder change, the important things to take away are these. The decision wasn't driven by a cost savings measure. In fact, in the initial comparison of replacement powders, there is no writing to be found on which powder would be cheapest. They weren't trying to sit here and corner cut and penny pinch. They were trying to find a powder that would work in the first place because 4475 couldn't. No matter how cheap or how expensive 4475 was, ammunition suppliers refused to load 4475 because it couldn't get spec velocity without being over pressure. This was completely independent of cost, and its replacement was picked completely independent of cost. Despite what the ICORD hearings and maybe other presentations on this topic will lead you to believe, the powder was not the major driver of failures. While it did expose the inadequacy of the buffer design, and it did cause parts in the guns to break prematurely, and those parts had to be reinforced, by the time the new buffer was implemented in 1966, and the time that retrofit was complete in 1967, the powder issue was more or less resolved as it came to an increase in rate of fire. And as you can learn about more on your own by reading the reports from the Panama trials, the rifles with their improved buffers using WC-846 ammunition were more reliable than rifles using IMR ammunition. The key takeaway there being WC-846 was a good, reliable powder, and the other issues that the rifle had, it had independent of WC-846 powder itself. This discussion now finally gets us ready to talk about that buffer design. The original buffer for the AR-15, as designed by Eugene Stoner at Armalite, utilized what's known as the Edgewater buffer. The Edgewater buffer had a series of rings and cones known as Edgewater rings that were designed to compress together as the rifle came backwards under recoil and then forwards under recoil, intended to eliminate vibration and dampen movement a little bit. However, compared to the overall cycling energy of the AR-15, the Edgewater buffer was always underweight, even for that 4475 ammunition. Because of this, paired with the fact that the Edgewater rings in the buffer could get wet or oily and then collapse and not manage to have any sort of vibration dampening effect at all, AR-15s would end up with dead triggers in a phenomenon known as bolt carrier bounce when fired in full auto. This video will show us what bolt carrier bounce actually looks like in slow motion. Pay attention here, this is the bolt carrier that we can see through the ejection window, and pay attention to what it does as it comes back forwards. After the round is fired, and the bolt closes, we can see it bounces a little bit there. And if we go frame by frame, we'll see that the bolt closes here, but then the bolt carrier bounces backwards about that far. In the AR-15's trigger system, the autoseer is tripped whenever the bolt carrier comes all the way to the forward position. However, if the bolt carrier then is capable of bouncing backwards, the bolt carrier will have the firing pin retract as the hammer is coming forwards, and the hammer will smack the firing pin while the bolt carrier and firing pin are in this retracted state. Because of this, the hammer will push the bolt carrier forward, but the firing pin won't come forward with enough force to fire the primer. As we see if we continue frame by frame, we can see about here, the hammer has just now smacked the bolt carrier while it's retracted. And while the hammer will then quickly shut the bolt carrier like that, that doesn't have enough energy to fire the next round, and we see that the gun doesn't fire. The trigger would be dead, and the rifle would need to be manually racked in order to get the gun working again. Just to show you guys one more time, the round fired, the bolt closes, the bolt bounced, the hammer drops, and then the bolt slams back forward. But this causes that dead trigger issue, that failure to fire issue, that existed even on the early AR-15s using 4475 ammunition, but after the increase in cycling energy resulting from WC-846 ammunition, this bolt bounce phenomenon became much more common. We can see here a comparison: on top the original Edgewater style buffer, and on bottom the improved buffer that Colt would eventually arrive at to fix this issue. The most important thing to note is that the Edgewater buffer is hollow all the way through here. There is no additional weight. The Edgewater buffer is quite a bit lighter than the actual final adopted buffer, and the final adopted buffer will still work with 4475 loaded ammunition, which should key you into the fact that this is a really light buffer design. In fact, lighter than a lot of competition buffers that people use in highly tuned rifles these days. The Edgewater buffer just was always a very poor solution. Even without the rings getting wet and the entire thing collapsing and sticking together, the gun could exhibit that light strike issue because it did allow a little bit of bolt carrier bounce. Colt was aware of this issue as early as 1963, before WC-846 had been used to load 223 Remington ammunition, and so Colt was already working on designing an improved buffer. In fact, in this bottom picture, we see a representation of one of Colt's prototypes as they were searching for that improved buffer design. This is in fact a machined nylon buffer that has steel weights put inside of it to try and get the bolt weight increased, because Colt realized right away in 1963 increasing the weight of the buffer is going to tend to make the bolt bounce a less severe issue. In mind, this was with 4475 ammunition that Colt discovered this problem. By the time WC-846 is in the mix, bolt bounce is going to be a more severe issue, and that's what eventually leads to the improved buffer that we know today. Ultimately, this issue isn't solved until 1966. During the Army's testing of the Armalite AR-15s, there in the 1950s, the light strike bolt bounce issue is noted, although based on all of the reports that I've seen and read, they never actually put two and two together and said that it was because of the buffer, or noted that it was because of bolt bounce that they were having light strike issues. They just noted that sometimes the rifle would have a dead trigger without firing the round. By 1966, Colt has designed, tested, and is ready to implement the improved buffer into the rifle. From that point in 1966, all new rifles will have the buffer, and by 1967, the existing rifles will have had new buffers sent out to them so that they can be retrofit and swapped with instructions to destroy or prevent the use of Edgewater buffers going forwards. In the end, it would be Colt that would find and then fix Stoner's mistake in the original buffer design. It was too light even for 4475, and while it's possible that Armalite might not have actually known or realized that this was an issue, they were certainly privy to the Army tests that had found that this light strike, no fire, dead trigger situation would exist in full auto, and it seems a little strange to me that they wouldn't have had time to put two and two together to say, this is what needs to happen and this is how it needs to be fixed. Certainly by 1963, Colt is on the case and is working on coming up with an improved buffer, and luckily it is able to be implemented quickly, because by the time WC-846 is the only viable powder, the rifle badly needs a buffer of an adequate weight and of a proper design to prevent this bolt bounce issue from continuing to plague the gun. That redesign and replacement that Colt does ends up doing the trick, and the raw number of failures that rifles have in Vietnam drops dramatically. This is because one of the most common reported issues was this light strike bolt bounce issue. While in the grand scheme of jams, it's a pretty easy one to clear, you simply have to rack the rifle. And the fact that it only affected full auto fire meant that there's only going to be a subset of situations when it was going to matter in the first place. The issue was fairly endemic, and it was something that needed to be addressed. Many people will point to the combination of the update to the buffer and the powder change to try and illustrate a story that shows that this was the serious issue the rifle was fighting. And in terms of raw numbers, it is true, it was the most common issue the rifle was facing. but it wasn't a particularly severe issue. It could be avoided in its entirety simply by running the gun on semi-auto instead of full auto. And with the buffer being implemented so quick and solving those issues from the powder change then and there, really before the conclusions from the I-Court hearings were even available, the whole public outcry and outrage over the issues the rifle was facing are pretty clearly not a result, at least not a direct result, of the powder change and of the issues with the buffer. Because, of course, the buffer was implemented by 1966 and was universal in the rifles by 1967, and the issues that the rifle was facing, those severe issues and failures to extract, persisted past this point. And as we explained earlier, even if 4475 powder was going to stick around, there was going to need to be this sort of updates happening with the rifle to make it reliable, because using 4475 would necessarily involve a reduction in cycling energy of the rifle that would likely have needed the Edgewater buffer to be redesigned because its design was insufficient in the first place, but then also a rebalancing of weights to take place to try and struggle with that bolt bounce issue. Ultimately, the implementation of the improved buffer design would sort of solve the issues that the powder change had exposed. And while those two factors are closely related, those are not the drivers of the most serious issues that the rifles were facing. Those issues were the result of a few more complicated factors which we will tackle in the next couple of sections. Next up, we have insufficient cleaning. In my opinion, insufficient cleaning and maintenance is perhaps the biggest issue that the rifle faced in terms of it caused the largest number of the biggest issues that the gun would face. Ordinarily, the blame for rifles not being properly cared for and maintenance falls on the individual level, if not the unit level, and typically not much larger than that. People not taking care of their equipment is a failure of the people not taking care of their equipment. However, the circumstances surrounding the AR-15's adoption makes this a little bit more complicated as it comes to this rifle. The big drivers of this issue were the instructions on use and care either being unavailable or not provided, or something that soldiers had to go and seek out without necessarily knowing exactly how they'd go and seek them out. And of course, why this would be an issue is very obvious. Dirty rifles will jam, they'll corrode, they'll have all number of issues because they aren't being taken care of properly. Now, other presentations will talk about this lack of cleaning or insufficient cleaning and end up working in some version of a story where either the Army or the Air Force or somebody says that the rifle's self-cleaning and doesn't need to be cleaned. I would like to present as evidence these two screenshots. The screenshot on the left is from a very early Army manual on the AR-15 M16. It's the beginning of the section on maintenance, where it goes through in detail how to take the gun apart, how to lubricate it, what lubrication to use, what cleaning kit to use, essentially all of the bleeding details of how to take the gun apart, take care of it, and put it back together. On the right is a capture from the Air Force's version of the manual, where they go over all the same things. This version of the manual is so early, they don't call it M16 yet. They're still calling it AR-15. This section in this manual goes through how to take the gun apart, how to lubricate it, what lubrication to use, what cleaning kit to use, and then how to put the gun back together. It goes over all of this. So, with the notion that the Army or anybody described these rifles as being self-cleaning and then didn't tell you to clean them and then there was no cleaning kits, I think we can conclusively say that idea is debunked. So where does that kernel of information come from, right? Because people wouldn't repeat it unless there was maybe some reason to believe it. My personal opinion, my personal conclusion is that people will take tidbits of truth from various different stories and try and make an amalgamation that resembles something believable, and it usually goes something like this. There is an early Colt advertisement for the AR-15 that describes the gas system, specifically the gas tube, as being self-cleaning. This was done because at the time there were a couple other direct impingement gas tube-based rifles, and both of them had instructions about cleaning of their gas tubes. Now, this was because they would be using corrosive ammunition, and the M16 AR-15 family didn't need that done because they weren't going to be using corrosive ammunition. But in this same advertisement, in this same push, even in Colt's own manuals for the AR-15, they talk about the fact that the rifle is otherwise easy to take apart and maintain. Because the rifle wasn't maintenance-free, the rifle wasn't cleaning-free, it just has a quote-unquote self-cleaning gas system. This would not be a universal feature, mind you, of Colt's advertisement of the rifle. I can really only find one time that it ever showed up. I can find 0 times in any Army, Air Force, or Marines documentation or publications where the rifle is discussed as being self-cleaning. However, what you can find is a couple of anecdotes that turned up whenever the Colt and the Army sent independent inspectors to Vietnam to try and understand some of the issues the rifles were facing. Some Marines and some Army soldiers that were interviewed said that they were told by their commanders not to clean their rifles. While I have not seen any of these interviews testify that anyone said that the rifles were self-cleaning, I think I'm not wrong to say that the people saying that there was some sort of self-cleaning directive that went out are taking a variety of pieces of these facts and putting them together to somehow try and say that, well, the Army said the rifle was self-cleaning, but when in reality we can see it here in black and white. They don't put this section 3 care and cleaning would say maintenance. Rifle's self-cleaning. Don't worry about it. Ha 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 is what it would say if they said the rifle was self-cleaning. Instead, they talk about technical manuals where you'd look to find the proper cleaning supplies to use your rifle. They talk about what kinds of oils to use and the cleaning kit to use and how to be careful with the cleaning kit so you don't damage it. They talk about cleaning the chamber. They talk about cleaning the locking lugs. They talk about care of the rifle from top to bottom. So, all that said, where did the issues come from, right? If these were the instructions, where was the failure in communication? Well, it's not actually the soldier's fault. At least not entirely their fault. Sure, at the end of the day, it is the responsibility of soldiers to take care of their equipment. I believe the Marines even have a very famous mantra that says as much. However, if it's the Air Force or the Marines or the Army, their management has some corresponding responsibility in making those cleaning instructions and making that best information on the care of the rifle available to the soldier. It shouldn't be entirely up to the soldier to know how to seek out this information. It's sort of a one hand washes the other situation, and due to the circumstances of the rifle's adoption, it really wasn't possible for one hand to know what the other was doing, let alone for the hands to meet up and there to be soap and water in the hands to get clean. What this really comes down to is the way that the adoption of the AR-15 actually worked out. The Army and the Marines were fielding and issuing a large number of AR-15s well before the rifles were officially adopted by either branch. The Army, of course, was calling them M16E1s, as was the Marines, but this designation was used because the rifles weren't fully adopted. Until they become M16A1, the rifles aren't officially adopted, and the standard rifle of both the Marines and the Army was still the M14. Because the M14 was still the standard rifle, and because AR-15s were in such high demand that all of Colt's production was just going straight to Vietnam, Army soldiers and Marines that were going through basic training and familiarization here in the US would be doing it on M14s. Then they'd be shipped out to Vietnam where they'd have an AR-15 put into their hands, a rifle that they've never taken apart, they've never fired a shot through, and that they have no familiarity with. And this familiarity is very important for a soldier to be able to take care of his rifle. A soldier has a large number of things that he is responsible for, and having to go out on his own to seek out field manuals on how to take care of his gun is certainly something that we hope the soldier would be able to do, but it's not something that the soldier can necessarily be depended on to go and do. Add to this the fact that cleaning kits were not always issued alongside the rifles. The assumption was that soldiers getting to Vietnam and being handed an AR-15 instead of an M14 for the first time would be able to go to their armors and their unit supply and logistics and get their field manuals and get their supplies and get their cleaning kits and know how to then read and understand everything that was going on was a bridge too far for some units. Whenever Colt and the Army conducted independent inspections and interviews of various units in Vietnam, they found that units where the field manuals were available, they'd also see proper cleaning supplies available, they'd see the proper cleaning kits available, and they would see that the rifles would be well maintained, they'd be relatively rust-free, and the soldiers would have positive things to say about them, that the rifles work great, or they saved their lives, or they're very happy with them. Meanwhile, while visiting with units where field manuals weren't anywhere to be seen, cleaning kits weren't anywhere to be seen, and cleaning supplies weren't anywhere to be seen, soldiers would be interviewed and admit that they'd never cleaned their rifle for the entire year or 2 or 3 that they'd have it. Soldiers would admit to using diesel fuel or other improvised lubricants and cleaners as a way to try and make the rifle work more reliably. And the picture that this painted for both Colt and the Army, and by way of the Army, the Marines, was that there was a massive failure in education that had taken place somewhere along the line. Of note, Colt would check with the Air Force to see what issues they were facing and would find that the Air Force, with their M16s, weren't really having very many problems at all. This can be easiest understood in that the Air Force supply chain was a lot better about getting manuals into people's hands, making sure they had the cleaning supplies, and ultimately the Air Force wasn't spending as much time in adverse conditions as the Army and the Marines were, and as such the rifles weren't getting exposed or used as heavily in those adverse conditions, and then subjected to the wear and tear that would result from those conditions if the rifles weren't taken care of. These issues persisted from the time that the rifles were first issued all the way through 1967. While in the very first battles that the AR-15 featured in, these issues weren't hardly anywhere to be found. specifically Ia Drang Valley, the first major battle for the U.S. in Vietnam, Hal Moore and Westmoreland, and generally the entire U.S. Army's response to the rifle's performance was extremely enthusiastic. It was the rifle's performance in that battle that convinced the Army that this rifle was worth putting up with, and potentially would be a worthy successor to the M14. However, given a year or two for those rifles to be neglected, issues would end up showing up. And while a lot of commentators want to say that, well, it was the powder change that was responsible for this, the powder change had taken place almost a full year before Ia Drang Valley takes place. Certainly WC-846 ammunition would have been in use in the battle, and yet there aren't these great reports of failures happening left and right with these rifles during the battle. The solution to the lack of cleaning kits and cleaning instructions was fairly simple. The Army hired a famous cartoonist to put together a now famous cartoon instruction set for the rifle. It was like sort of a hyper-sexualized thing that they would give to soldiers because it certainly makes it much more interesting to read than a dry field manual that sort of touched on all of the high points and the important things. Here's how to take your gun apart, here's how to lubricate it, avoid using lubricants that aren't prescribed here, avoid using methods for taking the rifle apart and cleaning the rifle that aren't prescribed here, and then here's how you put it back together. Additionally, an improved cleaning kit was designed. The cleaning kits that the early version of the manuals pointed to using were fragile, and the manuals pointed out the fact that they were fragile. A weak cleaning kit is certainly not something that you want to have for a rifle that you're going to have to be constantly cleaning. And so an improved cleaning kit for the rifle was eventually designed. Additionally, Colt and the Army would work together to add a storage compartment to the buttstock of the rifle so that the cleaning kit could be stored with the rifle itself. In addition to the instructions not always being available, as mentioned, a cleaning kit and cleaning supplies were something that had to be requisitioned separately of the rifles as well. If this didn't happen, you were left without a kit. Adding a way for the rifle to store that kit means that you could be issued the rifle and the kit alongside or even inside one another, and you would never be without those tools. Finally, perhaps the most important change that happened is that by 1967, the United States has committed to the M16 fully, right? They've adopted the M16A1 as their standard service rifle, and Colt's production has ramped up to a point that stateside, the United States Army can train their troops on M16s. As a result, the rifle that you train on and you learn everything about for the weeks that you're in boot camp directly translate to whenever you're stuck in country. And so while you're more worried about things like surviving, you already have it drilled into you how to take care of the rifle that's there to keep you alive. An additional care and maintenance item that often got neglected on the rifles was their magazines. Of course, the very early magazines did have issues, and as people retell this story, they'll oftentimes try and work in some version of the magazines being disposable. That was never the case with issued magazines. At one point, the Army did experiment with making a disposable magazine, which would be all polymer, would be shipped with the rounds in the magazine, and was not to be reloaded after use. However, the issued magazines for the rifle were not intended to be disposable items, despite how frequently people make this assertion. In fact, if we again look to the early manuals, again on the left, the Army, on the right, the Air Force, these manuals both have sections on care and maintenance of the magazine, especially as far as cleaning them goes. You don't clean and maintain magazines that are disposable, you just dispose of them. People say the same story about the M1 carbine magazines, by the way, as an aside, and again in its manual it has a section on care and maintenance of magazines. Now, both of these manuals for the M16s talk about the fact that a malfunctioning magazine or magazine that's consistently having failures to feed should be discarded and replaced. Bad magazines should be disposed and taken out of circulation. But this doesn't mean that the magazines are somehow disposable. Further evidence of this is the fact that the magazines have stripper clip guides on them, and they made stripper clip spoons to put ammunition in the magazine. You don't really need to go through all that effort if the magazines are to be disposed after a single use. And this is all, of course, because the magazines weren't meant to be disposed, and there were instructions on cleaning and maintaining the magazines. However, pretty much across the board, whenever the Colt and Army had their independent inspectors go to Vietnam to try and investigate issues, one thing that they found very frequently was that magazines were not being properly maintained. They would find magazines packed full of grease, and the justification for this was that it would lubricate the ammo, and then with the ammo being lubricated, the rifle must run more reliably. When in reality, the magazine packed full of grease just let sand and dust and debris accumulate in the magazine, get coated onto the ammunition, and then delivered into the chamber of the rifle to build up to the point that the rifle would then jam and become inoperable. The Army would revise its manual to include better instructions and better pictures for caring for magazines, but even the very early issues of it have instructions on caring for magazines. It's just that those instructions were very infrequently carried out, or when magazines were serviced, they were serviced incorrectly. At some rate, this justifies a fear that the Army had about mass issue of magazine rifles in the first place. They had sort of learned a lesson with the M1 carbine that having magazines in the hands of soldiers was going to be a problem, and before the carbine they even saw with the BAR, that it places a certain strain on the logistics supply chain because you're not going to be able to make enough magazines, that all of the ammunition provided comes loaded magazines, like was the case with the M1 Garand's clips. While Garand certainly did feed ammunition that wasn't just provided on clips, Garand ammo loaded into clips was an affordable way to supply them because the clips were so easy to manufacture. Magazines are certainly much more complicated, and so the logistics issues that they brought up, not just in supplying the magazines, but finding when magazines go bad and then pulling them out of service, presented enough hurdles that the Army was afraid that the exact scenario that ended up happening with the AR-15 would pan out. It may be difficult to sort of wrap your head around this these days. However, if you sort of put yourself in the Army's shoes, especially at the time, most people in the United States had not actually had a center-fire magazine-fed rifle that they'd shot at this point. While magazine-fed .22s weren't necessarily a rarity, and certainly a lot of handguns were magazine-fed, most Americans' exposure to firearms wasn't going to be through detachable magazine center-fire rifles. And so their overall familiarity with those sorts of systems and their awareness that magazines do eventually need to be cared for and maintenance wasn't going to be, part of this collective intelligence that people had coming into the service. Frankly, and in my opinion, I'm not sure that this collective intelligence is really there today, because very few people actually clean their magazines. You'll certainly find it with people who own suppressors and run suppressors do it more often because they make the magazines dirtier and get dirty to the point that they will stop working more often. But a lot of people aren't even aware of the fact that it's a real thing that needs to be done, that even with PMags, alloy mags, steel mags, regardless, it's a good idea to clean them. Of course, the manufacturer of your magazine should probably have some instructions on cleaning them, but the go-to instructions for the Army in the use of their magazines was to have the magazine be dry with no lubrication except a light film of oil on the spring to prevent corrosion. But this is just one of the lessons that Colt and the Army all sort of had to learn together here, again in the middle of a war. Wrapping things up here, I did want to include the cover and then back page of that cartoon manual that was put together. There would be several versions of this manual, and so this cartoon kind of became the de facto care and maintenance document for the gun, more so than the field manual itself, because it was much more digestible and much more to the point, and avoided that sort of excess, overly formal verbiage that isn't particularly helpful to soldiers. The next issue we'll be discussing is chrome plating, and really just the lack of chrome plating in the early AR-15s. For those unaware, chrome plating is done to rifles for two reasons primarily. The most important reason for our discussion here is for corrosion resistance. Chrome plating is essentially applying a thin layer of chromium to the inside of a rifle barrel, because chromium doesn't really rust. Throughout most of World War II, the major powers were using what's known as corrosive ammunition. This is ammunition that has some amount of salt either in the primer or in the gunpowder, so that whenever the gun is fired, there's actually corrosive salt that remains residual inside of the barrel or inside of the weapon's gas system. This corrosive salt needs to be cleaned out, or else the rifle can start rusting severely. Most of the instructions for use and care of rifles in World War II was built around the idea of cleaning the gun after you shoot it, but there wasn't always as heavy an emphasis placed on cleaning the gun if it wasn't shot. The United States Army and the United States Marines would learn this the hard way in the Pacific theater of World War II. There, their rifles, M1 Garands, 1903 Springfields, and the like, would be subjected to, in some cases, week-long downpours of rain that would certainly have washed any lubrication completely away from the rifle. As a result, whenever the rain stops, you now have residual moisture on bare steel that's going to end up causing rusting. The lessons learned there ended up becoming the emphasis for the United States Army to require that whatever its next standard service rifle was going to be required to have a chrome-lined bore. For them, come 1957, this would end up being the M14. Bear in mind that around this same time, the U.S. Army was involved in a push to get rid of and end the use of corrosive ammunition in general. The technology to make non-corrosive ammunition had existed for some time, but the big difficulty is that it required extra steps on top of what it usually took to make ammunition. And certainly there before World War II, there were enough variables at play that worrying about now making it non-corrosive was sort of outside of the scope of the technology, but certainly by the end of World War II, it was something that any major power could have tackled if it so chose. Of particular note, the first country to really jump on mass issue of chrome-lined bore rifles would be Japan, again in World War II. Their Arisaka bolt-action rifles, at least up until the sort of last-ditch rifles were being made, would have chrome-lined bores because they were aware of the circumstances of those sort of humid, extremely hostile, rusty environments. Now, even though the US Army had this requirement for their future rifles to have these chrome-lined bores, by the time that they're looking at and evaluating the AR-15, they're aware of the fact that it doesn't have a chrome-lined bore, but they're not necessarily looking at this as the replacement for the M14. The Army's testing at this time is just looking at, can a .22 caliber rifle be good in the first place? The answer they find is, yes, it certainly can be, but the Army isn't interested in adopting a new rifle at this time. This all changes in 1962 and 1963, where Department of Defense gets the bright idea that shutting down M14 production and having the Army and Air Force use AR-15s until a more suitable permanent replacement comes along is a good idea. The AR-15, as designed by Eugene Stoner and as manufactured by Armalite and as manufactured by Colt up to that point, never had a chrome-lined bore or a chrome-lined chamber. The Army, of course, really didn't like this and insisted that the rifle needed to have a chrome-lined chamber if they were to be using it. However, it was the Department of Defense that this time found themselves between a rock and a hard place. If they were to indulge the Army and allow these rifles to have a chrome-lined chamber, it would delay the adoption of the rifle by about a year or two, because the actual tooling and hardware and technology to chrome-line a .22 caliber bore and chamber didn't really exist yet. The American industrial base didn't have that capability. And while that capability could be built, this would be the pilot case for it, and so it would have to be built and then tested and then trialed to make sure that it actually works appropriately. It had taken a similar amount of time to figure this out for .30 caliber bores, but now that everything was shifting to a .22 caliber bore, all of that work would have to be duplicated. The Department of Defense knows this and knows that it can't stand to delay rifles for 1 or 2 years, because by this time they've already shut down M14 production, and the AR-15 really is their only chance to get the Army and the Air Force the rifles they need. And again, in the back of everybody's minds, there's this echoing whisper of, we could convert Garins to .308 in a really crappy, cheap way, and they'd work like really crappy, cheap rifles at that point. And because that wasn't an attractive option for anyone, the Department of Defense ends up asking Eugene Stoner his thoughts on the matter. Eugene Stoner says that the rifle is complete and mature, and it hasn't needed a chrome chamber in any of the testing so far, and so it clearly must not need it. And so the Department of Defense, relying on Eugene Stoner's advice, tells the Army, we're overruling you on this one. You're not going to get your chrome chamber on the rifle. Ultimately, this would be one of the worst decisions that happens for the AR-15, and while certainly the Army wasn't the bad guy here because they wanted the chrome-lined chamber and it was Department of Defense and Eugene Stoner who said they didn't actually need it, the Department of Defense at least had a legitimate reason for why they objected to the chrome chamber. It was going to make it so the United States military wasn't capable of procuring rifles for quite a while. Maybe they could look overseas and try and find something else, but this really wasn't a very attractive option. Meanwhile, if we do apply a cynical lens, the most likely reason that Stoner would say that the rifle doesn't need a chrome-lined chamber is because he doesn't start getting royalty checks and payments for the rifles until the rifles are getting procured, and the rifles won't get procured for another 2 years if we're going to wait around for chrome-lined chambers. Ultimately, it won't be until 1968 that chrome chambers for the M16 ends up being implemented. Their implementation is made most necessary and most obvious by those rifles that didn't have cleaning kits available, that didn't have cleaning instructions available, and they just weren't being cleaned for a year or 2 or sometimes 3 or more of exposure to the humid environment of the jungles in Vietnam. And while yes, in a perfect world, an AR-15 maintained as the manual said and kept clean and kept oiled wouldn't have needed a chrome chamber in the first place, the presence of chrome chambers and chrome-lined bores on a military rifle isn't necessarily there so that you don't have to clean the rifle. It's there for that if you're ever in a situation where cleaning the rifle isn't convenient. So a firefight that lasts longer than a day so you don't have time to get the corrosive salts if you're using corrosive ammunition, or get the rain if you're in a particularly humid environment out of the gun. The chrome chamber gives you that ability to not have to be extremely attention to detail about keeping your rifle completely spotless. That's the advantage of a chrome-lined chamber and a chrome-lined bore. And so while those instructions and those practices for the most part were in place by 1967 to keep the rifles from corroding and to keep that issue from happening, the chrome plating is at the very least a relatively cheap form of insurance to ensure that you're not going to have the worst of these issues that the M16 faces showing up if a soldier forgets to clean his gun. We have here a picture comparing 2 rifles. The rifle on the left was returned to the United States after service in Vietnam and was selected as an example of a particularly bad rifle. If you sort of look down there into the chamber, of course it's a black and white picture, it's not very great resolution, but if you look down into the chamber, you can see that there's no light whatsoever reflecting out of there. In fact, it's almost just pitch black. If we look at the rifle over here on the right, it's a rifle that's fired 10,000 rounds of ammunition, and you can still see light being reflected out of the chamber. The sort of important thing to pay attention to here is that a neglected weapon, even if it's not shot very much, that's just left to rust, will end up with a very, very poor condition chamber. Meanwhile, a rifle that is at the very least kept dry will have a shiny chamber and will continue to function reliably, despite the amount of soot and debris that builds up as a result of an extreme firing schedule. Another thing to pay attention to for the rifle here on the left is these series of marks down here at the bottom of the upper receiver. In my opinion, these marks are evidence of somebody sticking something like a screwdriver or some other tool up into the chamber area trying to pry out a stuck case. Because, as we'll elaborate on more later, a badly pitted and a badly corroded chamber will lead to a case that gets stuck in the chamber after the round is fired. Once a fired case gets stuck in the chamber, typically the bolt carrier's extractor won't be able to get it out on its own, and you'll have to take a ramrod from the muzzle of the gun and beat the case out of the chamber. For some particularly tightly sealed cases, this can take as much as a minute to clear, and limiting yourself to one round fired every minute before the next case seals itself in place is like muzzleloader territory, and it's really not a good situation to be in. Keeping a rifle from getting this badly corroded would be essential to having a reliable M16. However, as discussed, due to a combination of kits not being available or instructions not being available or soldiers just not cleaning their guns, corroded chambers were just a fact for some rifles, and as a result, they would be subject to the worst failures that these rifles can exhibit, that of a stuck case. To conclude our discussion of chrome plating in the M16, I would like to direct you again to the Panama trials. It's sort of the penultimate test of the feature-improved M16 versus the M16 without some of those improvements, and the big thing being tested in the Panama trials was the chrome chamber. There were two big takeaways in the Panama trials. The first was that WC-846 powder was more reliable than the latest and greatest IMR offering, regardless of if the chamber was chromed or not chromed. And perhaps more importantly, chrome plating reduced the extraction failures and pitting that were present in the chambers. And this was all the justification the Army needed to go ahead and greenlight two things. Going forward, all rifles would have the chrome chambers, and all existing rifles would have their non-chrome lined barrels replaced with chrome lined barrels. Eventually, the chrome chambers would become a chrome chamber and a full chrome bore. However, for the reliability of the rifle, the most important thing is that chrome lined chamber. A rifle with a good non-pitted chamber but a very badly pitted bore will still run reliably, it just might not be terribly accurate. A rifle with chrome lining in both will be very, very resistant to the effects of rusting and corrosion. The fifth item that we'll address is the general immaturity of the AR-15 system as a whole. Whenever we talk about this subject, we're not talking about the powder and the buffer, because those were certainly two immature design aspects, and frankly we could probably throw chrome lining in there as well. Those three things were all immature factors about the design, but I wanted to pull them out separate because they were such severe issues that data was taken and collected about the specific impacts that they would have. We'll touch on what those impacts were once more whenever we get to the summary, but the items that we're going to be talking about here in the general immaturity category didn't have enough data taken about them for us to be able to say conclusively one way or the other what these things actually affected in terms of rifle reliability. However, what we can say is that they would continue to be an issue had they never been corrected. So what these issues were a variety of minor things, mostly dealing with part interchange, rifle-to-rifle consistency, and one particularly serious one had to deal with brass hardness specs. Most of these issues existed from inception all the way through 1967 and 1968. It's in 67 and 68 that Colt finally has a solidified final design for the M16. And after Colt turns this design over to the Army is finally able to actually check Colt's homework. Up to this point, the Army's been relatively blind of what it actually takes to make a reliable M16. By the time that Colt shares a technical data package with the US Army, the Army is finally able to see underneath the hood what makes the AR-15 tick from an engineering perspective. It's from these tests and these insights that the Army is able to put together a list of 140 different places that there's dimensional interference or dimensional tolerances on the M16 that would result in the rifle maybe not being completely parts interchangeable, which is something that the Army wanted to do their best to ensure that the rifle was. Additionally, during these tests, the Army comes back to something that they had noticed all the way back in 1964, that there wasn't an established brass hardness spec. In 1964, the Army had brought this up as one of those things that it wanted to have before it would be using the rifle. However, like many of the other issues it brought up, Department of Defense told them it wasn't that big of a deal. Department of Defense's justification was, again, this rock and a hard place situation. They needed to get rifles out there, and they needed to get ammunition out there, and they needed to do it as quickly as possible. DoD looked to all of the testing that had happened prior, and both they and the Army couldn't really point to anything that said, look, there's an issue with the brass hardness that exists and we need to set a spec. Certainly, in retrospect, that was a really, really poor decision, amongst a lot of other really, really poor decisions in hindsight that the Department of Defense made around the time that they were rushing the development and adoption of the rifle. But again, they needed to have something for soldiers to be using. For a lot of these little immaturity items that the rifle had, you'll see a lot of different parties object. Most of the time it's the Army objecting, most of the time it's the Army finding things wrong with the rifle, and most of the time it's, then not the Army's fault, because in many of these cases, there's documentation of them objecting to these things before they were even using the gun. Back during the testing phase, they were objecting to many of these things. However, DoD, in their haste to solve the M14's problems and find something to hold them over until a suitable permanent replacement could be found, really wanted the AR-15 to just fill that gap as quickly as possible. And as could be expected, implementation of these fixes was done the hard way. A flawed design had to have its flaws identified, and it had to be fixed. I want to look closely at brass hardness because it is a potentially very important factor of the story. However, it's very difficult to say what impact it actually had, as we'll explain by the end of this section. Of course, as mentioned, there was no hardness spec established for the brass. The reason this is a problem is that cases are too soft can fail, typically during extraction. I have here two different pictures of 223 cases. On the left, you can sort of see what would happen during what's known as extractor lift. The case is soft enough that it deforms while the extractor is trying to pull the case out of the chamber, and the extractor just sort of humps back over the case head and leaves it stuck in the chamber. And you'll typically see a deformation like this. Letting the bolt come back forward and trying to pull the case out slowly can sometimes result in this case still being possible to extract. The more severe failure that can happen as a result of brass being too soft is what's known as a rim shear, where the extractor just takes a bite out of the case, swages this entire section off, and then leaves you with a non-extractable case in the chamber. This case would have to be beat out from the muzzle with a cleaning rod, or removed from the chamber using a screwdriver or some other tool. As mentioned, this issue had really always existed. The Army noted it in 1964, but it really wasn't until 1968 that it actually got fixed. It was in 67 that the Army told the ammunition manufacturers, hey, this is going to be the brass hardness spec, we're going to make it permanent in 6 months, and we're going to start rejecting ammo lots that don't conform within 6 months. And the ammo manufacturers fell into line then by 1968. Again, this is a situation where the Army identified this and the Army wanted this, and the DoD told them it wasn't very necessary. Again, rock and hard place. Was the DoD at fault? Yeah, sure, in hindsight they made a really terrible call, but their options were also very, very terrible. And you can point fingers in a lot of directions for why the DoD's options for alternatives were terrible, some of which is the Army's fault, but ultimately there's some combination of Army and Air Force and Department of Defense. Congress even shares some amount of blame in this story for the government as a whole having some number of failures that take place that leaves Department of Defense in the eventual situation where the M14 probably needs to go sooner rather than later. The switch is going to be shut off on that production, and we have to have something to tide us over until we have a permanent replacement. Eventually, the AR-15, right, spoiler alert, becomes that permanent replacement. But at the time that the DoD is rushing the adoption of this rifle, they're rushing the adoption because they want to be having something else here in 2 or 3 years anyway. And in that context, you're best able to understand why they would rush something like not having chrome lining, or why they would rush something like not having a hardness spec for cases, or why they would rush something like the buffer being underweight, or not actually having a fully mature cartridge powder design yet. Ultimately, the Army would characterize the effects of brass hardness in a series of tests and use that to say, this is the hardness range that we want for the brass in the cases to load 223. However, the important takeaway for understanding the brass hardness issue is that because there wasn't a spec specified from the beginning, there was no data taken on one lot of ammunition to the next. So if there was a particularly troublesome lot of ammunition, and engineers or analysts were trying to figure out if it was a result of powder or it was a result of dimensional issues, either on the ammunition side or on the rifle side, trying to figure out what the actual problem was, they wouldn't be able to look and see if it was brass hardness on its own. The Army did note this was a problem in 1964, but even then the data didn't start getting taken down until the Army demanded that it be come 1967, because they had characterized the effects and seen that too soft brass will result in severe cycling issues with the rifle. but how much overly soft brass actually contributed to those failures that took place in Vietnam, those failures to extract with rim shear or cases failing entirely, is impossible to actually determine from the data that we have because there wasn't actually any information taken as far as brass hardness specs across the ammo lots that were provided. Back to the discussion of general immaturity, this section from the Black Rifle sort of best summarizes the 140 areas of potential interference. The Army went through with a fine-tooth comb of Colt's engineering drawings to find anywhere that tolerant stack-ups would result in a situation where parts might not be 100% interchangeable. The Army found 140 places that this could take place in, which might seem like a really high number, but when you get down to it, the M16 has quite a few pieces and parts in it, and when you consider that just the hammer of the gun has about 100 dimensions on it, it's certainly able to understand how 140 offensive dimensions isn't that many in the grand scheme of things. However, the Army did rightly point out that by this time, 500,000 M16s had been procured, and they hadn't been procured to a set technical data package, meaning Colt could sell you anything saying it was an M16, and it didn't have to be dimensionally or functionally identical to any of the other rifles that it had ever sold you, because there wasn't that firm engineering handshake in place yet. And so the quote from the Army around this time is that the production of large quantities of rifles, about 500,000 by this point, without a technical data package, has undoubtedly resulted in the introduction into the supply system a large number of weapons with non-interchangeable components of unknown quality. Now, this certainly is a little bit hyperbolic, but it does drive home the actual point of this design immaturity. Because the Army hadn't had access to Colt's drawings up to this point, and because Colt hadn't actually gone through and done a very serious interference check themselves, it was impossible for the Army to be sure of the actual state and situation of the 500,000 rifles that were already out there. The Army wouldn't be able to really say for certainty if a rifle that was made in 1968 would be fine to use a bolt carrier from a rifle made in 1964, because Colt had made engineering changes along the way. Would any of those engineering changes, combined with the other changes that had taken place with the rifle thus far, end up causing some incompatibility that would become endemic if a lot of rifles were so configured? This is the problem that the Army has to stare down the barrel of. And while ultimately Colt's engineering practices were good enough that this sort of situation was avoided, it was something that the Army had to worry about the entire time. Finally, on that note, because the Army didn't have the TDP until 1968, the Army wasn't really able to do a lot of serious hands-on testing of the rifle itself to characterize and understand the rifle. What I mean by that is the Army wasn't able to say, well, we know this rifle is on the excessive side of this dimension, and this rifle is on the minimum side of this dimension, and we're curious on putting ammunition of this spec or that spec in each of them and comparing the two. Because the Army doesn't know what the upper side of this dimension is, and they don't know what the lower side of this dimension is, because Colt is not under an obligation to tell them. By the time the Army has that technical data package, they're able to do this sort of testing. And Frankfurt Arsenal in 1968 does a bunch of this testing, and they find inconsistencies all over the place. They find inconsistency in the dimensions on Colt's guns. They see that Colt in some places is slipping on their QC, or they're fitting parts together in a slightly shoddy way. They're using chamber reamers past the point that they maybe should be using chamber reamers, and chamber dimensions are coming out inconsistent. What this all amounts to is that, of course, by 1968, the rifle had most of its issues worked out. But one issue that could then never be worked out of those first 500,000 rifles is that their level of parts interchange is almost impossible to qualify, because Colt was making rifles willy-nilly even after they handed the technical data package over, and it's because the Army didn't really have a way to check Colt on this, and Colt was just there trying to make rifles as quickly as they possibly could. And so ultimately, these sort of issues, these sorts of immature, like very early, trying to ramp up production as quickly as you can issues that would find their way into the rifles, could have had some amount of impact on the actual overall performance of the thing. And how much that impact can be, we'll never actually really know. Finally, we find ourselves at the conclusion. You'll have to bear with me because we will have a lot of reiteration in this section, because that's sort of what conclusions are for. Jumping right into the first item, the AR-15 M16 did have serious issues. I don't want you guys to hear what I've said thus far and take that as understanding that, well, the issues were very minor and they didn't actually matter. The issues were pretty important, and had the issues not been solved, the rifles would have continued to get a worse and worse reputation. And certainly, at the end of the day, the issues the rifle faced were all fixable and to some extent preventable, had the rifle been given ample time to develop before it was being pressed into service in a war. The work that Colt and the Army and all of the engineers involved did together is really nothing short of miraculous to take a rifle that was so immature and bring it to the point that it was one of the most reliable rifles on the face of the earth in the span of about 4 to 6 years. It's uncommon to see a rifle mature that quickly in peacetime when it has all of the resources available to it and there's not conflicting information coming in. For that to be pulled off in the middle of such a high-stress, high-stakes scenario is really impressive. Secondly, I wish for you to take away that the cause of the issues the rifle had is not a one-size-fits-all answer. In this discussion, we touched on 5 major issues, the first of those being the powder change. Ultimately, what that did is reveal inadequacies in the buffer design, in weak parts in the gun in general, and allow those to be beefed up and reinforced, and then, of course, the buffer design to be implemented. And the powder change, to reiterate once more, needed to happen. It was the least bad option of all of the options available to all of the concerned parties there in 1964. Not changing the powder would have been far worse for the rifle than changing the powder. And to the whole silly sabotage story idea, if the Army was interested in sabotaging the rifle, all they had to do is show up to the Department of Defense and say, nope, the powder doesn't need changed, it's great like it is, and they'd have rifles exploding within a year. And of course, remember that issue is necessarily intertwined with that immature buffer design, that being our second issue. The largest number in terms of sheer number of failures came from this bolt bounce issue in full auto. Fixing the buffer and making it a good, sturdy design, one that is sort of the standard for buffer designs that we use today in our modern AR-15s, was necessary for the rifle to overcome that aspect of its immaturity. Those issues are certainly interlinked, and while they do have a little bit of crossover into some of the other issues, all of the postulation that takes place that the powder changed the dwell time and the cycling time, and that's what made the failures to extract happen, isn't actually backed up by the facts and the data. The substantially lower chamber pressure of the WC-846 ammunition, even though it had a slightly slower burn rate than IMR 4475, meant that in the case of having a pitted chamber, cases weren't going to seal themselves into those pits quite as tightly because you didn't have as much pressure doing the sealing and doing the forming into those pits. And additionally, you'd have a little bit more energy in the extraction cycle to get those cases pulled out of the chambers. A complete reading of the 1968 Rifle Review Panel report will show you that when using WC-846 ammunition, the incidence of failures to extract tended to go down, all else being equal. And of course, that discussion of chamber pits brings us right to the third and perhaps biggest issue the rifle faced, a general lack of awareness or availability or cohesive instruction on the use and availability of cleaning kits and supplies and instructions. Colt and the Army both had independent reports where they both confirmed the same things, where units that were taking care of their rifles had their rifles worked well, units that weren't taking care of their rifles saw them fall into a serious state of disrepair. No amount of lubrication or preventative maintenance would fix a rifle that already has a badly pitted chamber. And so preventing those pits from showing up in the first place was the most important thing a guy could do to keep his rifle in working condition. And of course, hand in hand with keeping your rifle in working condition, having a rifle that just isn't as susceptible to having rust take over its chamber and bore in the first place is a great thing to have. And so the introduction of chrome lining in conjunction with the improvement of those instructions helped the rifles get to the point that they could perform in the way they needed to without being overly susceptible to the humid environment and without having to be overly reliant on soldiers sticking to their cleaning and maintenance regimens. And so these two issues are very much intertwined and, while still connected to, distinct of the powder change and the updates to the buffer. And finally, that last issue that we talked about, all of the little stuff, including the brass hardness spec being established, all of the little things that typically the Army would address before it's adopting and using a rifle, but the DoD circumvented in this situation, presented their own little individual landmines, if you will, in this circumstance. And while these minor issues and the impact they had are much harder to quantify because they weren't closely tested for in things like the 68 Rifle Review Panel report, it should go without saying that not having a brass hardness spec meant that some brass was too soft and would refuse to run in these guns. And that having one rifle leave the factory one day and a rifle leave the factory the next day, and those rifles not be very parts interchangeable, and those rifles perform differently when fed the same ammunition, certainly put yourself in a situation where trying to track down and nail down the issues the rifle has is very, very difficult when you can't say M16 and have it mean just one rifle. It actually means a very, very small series of rifles that all say M16 on the side, but each have slight differences as Colt is working out the design in the middle of mass production for rifles that are going to be used in a war. With that reiteration of the issues and their impacts out of the way, I hope you guys can understand how I would take issue with any discussion of this topic that doesn't touch on at least those issues. Any sort of discussion that says that, well, it was just one of these factors and really all of the other ones weren't that important is wrong. And it's lacking not just in context, but perhaps even in honesty to some extent. Finally, and this is a very important point, we've watered this seed a little bit and we'll dump a fire hose of water on it here in a moment, but growing pains are a fact of engineering. Especially whenever you take a rifle that's really only seen low rate, maybe a couple thousand of them made, and you're going to scale that up to 100,000, 300,000, 500,000, and you're going to be scaling it up so just that you're making like 100,000 plus rifles in a year, is going to see a number of issues brought to the forefront. This is normal. This is the way that this engineering exercise goes, especially for military contracting, because these things will have been tested, and the tests are usually well-intentioned and well laid out. But once you actually get these things into the hands of their end user, and they use them in the awful conditions that wars necessarily involve, all sorts of problems are going to end up showing up. This was true of all of the rifles that came before the M16, right? We saw it with the M14, we saw it with the M1 carbine, we saw it with the M1 Garand, we saw it with the 1918 BAR. These growing pains are really just a fact of life of the military firearm, or even just engineering challenges in general, independent of if the military is going to be using them or not. However, what ultimately sets the best designs apart from the good designs is that the best designs are those that can adapt to these realities. And I want that to probably be the strongest, maybe most sentimental takeaway here for the AR-15, is that despite the almost impossible adversity it found itself in, a very steep uphill engineering battle that it was facing, it managed to not just crest that hill, but continue climbing to the extent where, when we consider great modern military rifles today, one of the rifles that necessarily gets its hat thrown in the ring is a rifle where the core mechanism hasn't really been improved since the 1960s. And that is a really, really cool thing. And I know people will point to the AK and say, well, yeah, but what about the AK? The AK took a good 10 years for the Russians to figure out how to make it work good and reliably and how they could scale up the mass production so that the rifles would be as consistent as possible and consistently reliable. It had its own growing pains and it had its own challenges to adapt to. And while the AK has certainly proved itself to be one where the design can be adapted to a lot of different roles, it's these designs that can adapt that find themselves coming to the forefront, and that even 60 years, 80 years, whatever, after their inception, they continue to have their names thrown in the ring as, well, this is one of the best guns ever that you can buy today, despite the fact that it was designed half a decade ago. It's very impressive. Finally, I want to address 2 points about other presentations of this topic. Typically, people who present this topic will try and put blame on just one party or just a few parties, or they'll say that just one or two things are wrong, and they'll typically leave out any discussion of justification. So they'll say something like, the Department of Defense dropped the chrome lining requirement. Or, worse, they'll say the Army dropped the chrome lining requirement when the Army was the one that insisted on it. But even if they get the facts right and say, well, Department of Defense dropped the chrome lining requirement, and how dare they got people killed. It's true that in retrospect, that decision was a really, really bad call. However, had DoD not made that call in 1963, come 1965, the United States' involvement in Vietnam is there. They wouldn't have any AR-15s at all. Ia Drang Valley would have been fought with M14s, and probably at that rate there wouldn't have been enough M14s, so it would have been supplemented by M1 or M2 carbines, heaven forbid Garands, and 1918 BARs. I again hope I don't have to explain to you why that would have been a really, really crappy situation for them to be in, going up against SKSs and AKs. It's entirely possible that Ia Drang goes very differently than how it went, if the US doesn't have the serious bolster and firepower that the AR-15 afforded them in that battle. And so while it's easy to point the finger and say, well, DoD messed up in retrospect, if DoD hadn't made the decisions they made, there wouldn't have been these rifles around for those first years in Vietnam. And that would have posed its own separate, distinct set of problems, where maybe we could make a what-if video where we specifically discuss what that would have looked like, but I can tell you that it wouldn't have been great. Finally, I want to wrap up this part of the conclusion section by saying that anyone who proposes you that just one or two parties or one or two things were wrong and that was it and that's the whole story, right? It's one issue to blame and one person to blame, or just one or two issues or people to blame and that's what was wrong. They're either ignorant or they think that you're ignorant, and they're trying to sell you some abbreviated version of this story that gives you a smaller than full picture. The defect of a smaller than full picture is that in this context, it leaves you with conclusions that aren't true. Like if your only understanding of what went wrong with the gun is that the powder changed, and you don't understand why the powder changed or how the powder change ultimately was the only reason the rifle was able to be adopted and fielded in the first place, and that the rifle wouldn't have even been capable of being fixed if the powder hadn't changed, you're going to come away with a perception of events that's just not rooted in reality. Because of course, right, we now understand if the powder doesn't change, the rifle can't be adopted because there isn't even enough ammunition for the rifle to be adopted in the first place. So while I'm not necessarily saying that you have to go and be mean to or call out people that are making lazy videos recounting this history, what I would suggest is that when you see somebody who's parroting that version of history, because it has been the story of the rifle that's been told for the past 50 years at this point, politely correct them, politely point them to the better sources of information, right? You can share with them the link to the Black Rifle or the 68 Rifle Review Panel, or even this video, and say, hey, I think you might have your facts a little bit skewed. There's a lot more to it than that. And I hope that this quest to have a better understanding of these events ends up raising all boats, right? It's sort of like a tide of information, if you will, where we all end up having a better understanding and appreciation of the history and engineering that took place if we understand more of the facts that surround these circumstances. Our final slide, our final part of the conclusion, is that aforementioned water hose that I'm going to turn on that second bucket. Now, for you to understand this, what I want you to do is picture in your head the reputation of the M1 Garand rifle. Okay, you got that in mind. Now what I'd like you to do is picture in your head the reputation of the M1 carbine. Okay, now that you've got that in your head, compare that to the reputation that the M16 has, or had, perhaps more accurately. Okay, in order, put the reputation of those rifles down in a list. You'd probably put Garand first, and then carbine second, and then M16 third, and it's a distant third, right? Because the perception of it is it's a very bad rifle. Okay, what if I were to tell you that the trials where the M14 and the FAL went head-to-head had the M1 Garand show up as a control, sort of to get an idea of how reliable the M1 Garand was, to collect data on that? What if I told you that these tests were controlled, and of course they were a little bit of severe conditions testing, but it was certainly nothing near as bad as you'd see in a war? Of course, we'd accept that. That's how that testing did go. What if I were to tell you that the Korean War production era Garands that were used as controls in these tests, in several of these tests, performed worse than the worst reports from combat of the AR-15 in Vietnam? You'd probably say, well, that's strange. While it is true that these Garands are sort of regarded as the least reliable Garands, we certainly don't run around saying the government sabotaged the Garands in the Korean War and it got a bunch of our boys killed, because that's nonsense. Yet the rifles that the US government was procuring, those new manufactured Garands during the Korean War, at the very least had some examples that were less reliable than the reports of reliability that were coming out of the Vietnam conflict for the M16s. To put that in perspective, what that really means is that even with the lack of care going on, even before any of the fixes or the issues were addressed in the M16, it was holding about par with how you would expect the M1 Garand to do. This is pretty shocking to hear, but was just the way those numbers shake out. And while it's true, right, the criticism there is that, well, one failure doesn't necessarily equal one failure. A lot of the failures that the Garand has is a failure to chamber around where the charging handle just needs to be bumped forward. And a lot of the failures that the M16s were facing in Vietnam was a failure to extract that required the round to be muzzle loaded out of the gun. Much more severe failure in the case of the M16. But in terms of raw numbers, the M16 and the Korean War M1 Garands were pretty comparable. If we introduce the M1 carbine into this mix, we'll see that the M1 carbine's failure rate was about on par with the worst recorded failure rates of the M16 on average in Vietnam. The rate that they would tolerate M1 carbines jamming or failing at was on par with the worst it got for M16s. And of course, we understand most of those failures with carbines was again magazine and feeding related issues where you just had to rack the bolt again to get it to fully chamber. However, the perception of the Garand and the carbine is that they are much better than the M16, when in actuality, the peak of issues with the M16 saw them about on par with those two guns, and certainly by the time that the buffer was fixed to address the issue with the ammunition increasing the cyclic rate, the real issues that the M16 was facing had to do with troops not taking care of them, and in the instance of the guns that were taken care of, they were much more reliable. Even in the cases of the guns that weren't being taken care of, if you averaged them up with the guns that were being taken care of, were more reliable than the M1 Garand, and were more reliable than the M1 carbine. And this brings us to the words that I have put on this slide, that there is no news quite like bad news. Simply put, the United States wars in World War II and also in Korea were generally pretty popular in terms of public perception and conscience. Certainly with the former, there's a lot of patriotism, a lot of pride that is associated with the United States going and liberating and spreading freedom across the world with M1 Garands. It's a trope that's in movies and video games and is very easy to identify with as an American. This is true to a lesser extent in Korea, but is still true to some extent in Korea, where the Americans stand against the unwashed communist hordes. But come Vietnam, you see a giant paradigm shift in the U.S. public's willingness to support a war that the United States got into. The war is deeply unpopular, and one of the most catchy stories that comes out of the war is that, look, this brand new rifle that we're using is having some issues. News crews had unprecedented access to the war in Vietnam and wanted to bring that into people's living rooms, and with as unpopular as the war was, no story would sell quite as well as, look, we're talking with the soldiers here and their rifles that don't work very well. Certainly the news crews wouldn't want to tell you that the rifles were working great, because that's not what the American public wanted to hear. They wanted to hear that the unpopular war was going bad for the United States because the United States' involvement was frowned upon. Because of this, the story of the M16's teething issues all of a sudden becomes front-page news. It becomes the subject of congressional inquiries. It becomes the most interesting thing happening that week. All the while, there in the small print, the rifle's reliability is about on par with the stuff that we've used before it. And while it certainly could have been better, and the stuff we used before it was hardly a paradigm of reliability, we don't look at the Garand as an unreliable dog that was intentionally sabotaged to get people killed. And a lot of people still look at the M16 that way. And I think these two things have to be kept in context with each other. Yes, the M16 did have issues that were very severe, those failures to extract. But if we just go and look at the M1 Garand, we'll find something a little shocking. The M1 Garand in World War II had an issue on it known as action freeze that was discovered. Action freeze would happen whenever the bolt and operating rod would lock up tight against the receiver and either require partial disassembly of the firearm or a swift kick to the charging handle to get it unlocked. The U.S. Army was able to establish that action lock was typically caused by binding between the cam lug on the bolt and the cam track on the operating rod itself, and that when these two areas were kept sufficiently lubricated, action freeze typically wouldn't happen. However, the lubrication typically used was very susceptible to rainfall. Rainfall was capable of washing this lubrication away, and action freeze would become much more frequent, in some cases happening as frequently as every 500 rounds. This was a known issue, and the U.S. Army investigated a series of fixes. One of the fixes that they found that would come close to solving the issue was adding a roller lug onto the bolt, like we'd see later implemented on the M14. However, after determining that this fix would actually be quite good, the Army sat there and looked at what it would take in terms of logistics and in terms of money to fix this problem on the M1 Garand, and they deemed the issue not worth fixing. They put a price on soldiers' lives, and that price was the cost of fixing 2 parts on the M1 Garand rifle. Ultimately, the Army would end up devising a lubrication that, while not quite as good at lubricating, was much better at water resistance, and called for using that on this area to try and prevent action freeze. Action freeze continued to happen with the M1 Garand, and action freeze even showed its head again in Korea, and yet the Army never implemented the roller lug design on the M1 Garand. This is a fact of the M1 Garand's development, and I know a lot of people who are very proud of the M1 Garand, I think it's a very American implement, don't like these facts because it makes them feel uncomfortable. It makes them feel weird that the very cool rifle that the United States used in World War II had cost-cutting things done to it that endangered soldiers' lives. This is a real thing that happened with real documentation to back it up. It's real cost cuttings to the detriment of our warfighters. And yet the Garand is remembered so fondly as the rifle that won World War II. It's the rifle that held off the Chinese waves in Korea. It's a symbol of American pride and patriotism, in stark juxtaposition to the M16, which is the rifle where there was corners cut and there was cost savings, and it was just the government out to get the soldiers because they were unwilling to spend more money on a rifle. When in reality, the issues that the M16 had were addressed very quickly, even though they were very expensive, including replacing entire barrels on rifles, which was certainly way out of the picture for the Garand, right? Replacing a bolt and an operating rod is certainly nowhere near as complicated as replacing a barrel on a Garand, and they wouldn't even spring for replacing the bolt and the operating rod. And so I want to leave you with those thoughts that at the end of the day, in that bucket of maybe it doesn't really matter that much, we pay particular attention to the M16 and the issues it faced for two reasons. The first is because the M16 and AR-15 have sort of become a football of American gun control politics, and that is very near and dear to me and many other people like me, gun owners who wish to be able to own things that the Second Amendment says that we have a right to own. But also because the Vietnam War, even all these years, all these decades after it happened, still has a lot of influence on the way that modern American politics looks. It was a war that showed that no matter how great living in America is, or how great living in America can be made to look like, there's going to be people out there in the world who don't want that want something different. And no matter how many bombs you drop on them, they're not going to change their mind about it. These political lessons, among many others, sort of served as the foundation for why the war was so unpopular. And that unpopularity is still a popular story today. And the trauma associated with that war, especially on the American psyche, gives the AR-15 and the M16 and the story of its issues such staying power in both gun culture and popular culture and even beyond that. With those thoughts, again, very much my opinion here at the very end aside, I would like to invite you guys to check out my Patreon if you are so interested. You can support me in making more videos like this or videos not like this at all. I usually just talk about shotguns for a very long time, or 3D print guns, or do all manner of other things. But sometimes I do these deep dives on gun history because it is very, very interesting to me. And so you can go and support me over there on Patreon. And then, of course, I would like to hear from you guys in the comments as far as if you felt that this presentation format was good, maybe room for improvement in certain ways. I hope that it wasn't overly academic, the whole talking over a slideshow thing. And the thing I hope most for is that this has been a slightly more concise, I'm sure this has already been over an hour long, but hopefully a concise, a not quite bite-sized, but maybe like N5 bite-sized way for you to tackle with and deal with the story of the M16 in Vietnam. With all that said, I hope that you guys have a nice time. I look forward to hearing from you guys in the comments, and I look forward to seeing you guys in the next video.